Okay, guys, um, ooh, I said that I would record the last 5 questions so that in case you needed a little bit of a reference that you had something to look back on. So I'm going to go through 11, 12, 13, 14, and 15 from our marking period to week 8, day 1 notes on solving log. So today I just want to refresh your memory. We're talking about when there is no log. So you just have a situation where you have bases and powers, okay? So we need to really focus on equating our bases, okay? So looking at number 11, just like in class, we want to make sure that we equate the bases. So you have a 9, a 3, and a 27. So the base that you would choose here is the smallest 3. So I want 9 to the x to be 3 to some power. I want the square root of 3 to be 3 to some power. And I want 27 to be 3 to some power. Now I put the parenthesis just in case that they already have a power, like the first 9 to the x already has a power. These two don't, but I just put the parentheses because. All right, so 9 is the same as 3 with 2 powers. So this is simply 3 to the 2x. The square root of 3, a radical gives me a fractional power. So this is 3 to the 1/2 because the root is 2. So this is just 3 to the 1/2. And finally, 27 is 3 to the not 2, but 3rd power. Now I'm in a sea of base 3, which is awesome. Base 3, base 3, base 3, they're like terms. So what I'm going to do now is I am going to combine, so I only have one base per side. So I'm going to take this 3 to the 2x times this 3 to the 1/2, and multiplying means that I will add those powers. So it'll be 3 to the 2x plus 1/2. And this side is already just one base. All right, at this point, what I'm going to do is I'm going to do log base 3 and log base 3. I did it to both sides to keep it nice and even, and they get rid of my bases. So you're left with an equation 2x plus 1/2 equals 3. All right, Miss Frebush, I'm not a big fan of fractions. Me either, kids, I'll be honest. So sometimes you can change them to decimals and it makes your life easier. So I'm going to change this to 2x plus 0.5 equals 3. So now I can minus the 0.5 minus the 0.5. This will leave me with 2x equals $3 minus 50 cents is $2.50. So now divide by the 2, divide by that 2. 250 cut by 2 is going to be 125. Not a beautiful answer, but certainly one that you can find. All right, number 12, you all were telling me you're intimidated by this one. I know. The problem with this one is you have to go lower than what they gave you. Here we had the 9 and the 3 and the 27. We're like, 3 is the lowest. Here you have 1,100. They can go lower than this. The good thing is they're going to go to 10. 10 is one of our favorites, especially with log. So the base I'm going to choose is the smallest that they both can be, which will be 10. So I want this to be 10 to some power. And I want this to be 10 to some power. All right, so 100's nice. That's 10 squared. This guy here is already on the bottom. So he's going to be negative. And there's 1, 2, 3 zeros, so it's negative 3x. Yes, it already had the x, but yeah, I'll put it there. So now if I log base 10 both sides, the 10s will go away. negative 3x equals 2. Divide by negative 3, divide by negative 3, x will equal negative 2/3. Not gorgeous, but you can do it. Yes, Miss Freibush, you're doing harder ones. I know, I know. All right, let's go to 13. I have 16, 64, and 256. Yet another one where we're going to have to go lower than what they gave us to start with. I have the 16, I have the 64, and I have the 256 from previous problems. I know my base here should be a 4. So I need this to be 4 to something over 4 to something equals 4 to something. All right, this guy already has a power of x. 16 is 4 squared. 64 is 4 to the 3rd. And 256 is 4 to the 4th. Ms. Freibush, how did you get that? Well, I could take 256 and I could divide by 4. And that would give me 64. Divide by 4. That would give me, what is that, 16? And divide by 4. That would give me 4. 1, 2, 3, 4 of them. Okay. Divide. I have to make this to be one base. Dividing means subtract. So this will be 4 to the 2x minus 3 equals 4 to the 4th. Log 4 will cancel and cancel. 2x minus 3 equals 4. Add 3, add 3. 2x equals 7. Divide by 2, divide by 2. X is 7 over 2, or 3.5 if you love decimals. All right, next one. I have 125 and 625. They end in 5s. I'm imagining 5 is my best friend, but we shall see. Base 5. So 125, if I divide 125 by 5, I get, what is that, 2, 25, 5 and 5, 1, 2, 3 powers. 125 is 5 to the 3rd. And it already has the x. 625 is just 5 times 125, so it's 1 more power, 5 to the 4th. Log base 5 on both sides. These cancel, 3x equals 4. Divide by 3, divide by 3. X is 4/3. And here comes 15. 15 is very similar to the one we did up here, number 6, when we said, okay, we could divide by 4 here, or we could have them both be the base of 2. In this situation, this is a base 3, and 4 will never be a base 3. 108 is neither a base 3 or a 4, so this one, because I'm solving for x, I'm going to divide by that 4 right off the bat. This one I didn't have a choice. This one I actually have to get rid of that extra 4 up front. So 4 goes into this 2, 7 times. All I did was 108 divided by 4, whether it be in your calculator or phone or what have you. So now common base is 3. 3 to the x equals 3 to the 3rd, and x equals 3. All right, guys, hopefully these questions at least help you a little bit with it. If not, ask me more questions and I'll be glad to help. Have a good one, guys.